We are going to spend this week talking about the exact other half of Arduino, or the Arduino experience, which is the outputs. And so this is sort of looking at a high level view. We're going to talk about outputs in general, which let your electronics come to life. These are the parts that go beyond them sensing their world, and they instead give it an ability to act and do things. So I like inputs a lot. They like give a sensation, but outputs are where you can start to make things that are magical happen in a lot of different ways. And so we're going to take a look at these things and see what's up. This is, again, got a series of steps. It's going to follow fairly similar to last week. We're going to go through 25-ish outputs. Some of them we will already know, like LEDs are a whole category. Light is a whole category. And so we're going to look at that. We're going to go through pulse width modulation theory, what that is, what it does. We'll go through its essential outputs, things that absolutely you should know about, just so that you know that they exist. And there's tons of different variants of those. Then we'll talk about motor controllers, because a lot of what we're going to be doing is focusing on things that move. Then libraries and protocols, and then some tricks, some things to do. So first up are 25 common electronics outputs. And so these are not necessarily the most common, but they're 25 good ones to be aware of. Oh, and I need to change that slide. It says 20. I was thinking about lowering the number for a minute, but we've got 25. So just to wander through these, we're going to take a look at how they fit in these categories. We've sort of got motors, light, non-standard motion, which is an interesting category for sure, power, and audio video. And we're going to spend a lot of time today on the motor section, because there's a lot of different motor categories, and I want to help decode those so that you know sort of what you're looking for if you wanted to decide you'd like a project to move. So we'll talk about brushed motors, and those are the most traditional, maybe the easiest to use motors. You hook them up to a battery and they just run. Brushed DC motors, with or without gears, they can happen. Then there's brushless DC motors. Those are like drone motors. We won't talk about those as much, but they're totally interesting things to have. If you want to make a drone, sort of the dynamic between how they play decides how the drone spins and moves, right? Drone wings are all fixed, but the amount of spinniness is what decides it wandering back and forth. Then there's hobby servo motors. So if you've ever played with an RC car, an RC plane, an RC boat, there were very likely hobby servo motors involved, especially if it was a high-end unit that somebody built. So we're going to take a look at those. Then there's stepper motors, which is a whole category that is really deep, but is not as easy to get into. Stepper motors, though, are what's at the core of making 3D printers work very visibly. It's also what makes the laser work, the vinyl cutter work, the CNCs work, and the water jet. Every single one of those is based around stepper motors and the precision that they give you. Then there's industrial servos, which are like an amped up version of servo / stepper. And it really sort of gets at the heart of feedback within those motor systems. But those are probably beyond what we're going to do. If you want a good example, though, I think that's what Mark Grober used in his dartboard that would always be a bullseye. I think he used those. Then there's the light category. And so we've talked a lot about, we had an LED week, so we talked a lot about those. Single LEDs are the most raw and basic. Then there's RGB LEDs, addressable LEDs, incandescent bulbs, like regular old light bulbs. And then I put in other bulb technologies, because you can absolutely do interesting things with fluorescent bulbs. We use them in industrial sort of settings because they're cheap and easy. But if you're holding one near a Van de Graaff generator or a Tesla coil, they also light up even without being plugged into things. So like there's all sorts of cool ways that you can make light happen if you're really into it. Totally worth experimenting with. Non-standard motion is also a fascinating category. It's other ways to get things to move, like pneumatic actuators, which is what will connect and disconnect the tools in the shop, in the Gerber and in the Tormach. So like to disengage the collets that hold tools, there's a lot of pneumatic actuation there. They also can be used in soft robotics, which is a really interesting category. Most of the time we think about robots as big metallic things, but there's this entire branch of research around soft robotics where they're like air bladders in plastic bags, and they sort of grow and squish. I'll put some links in the chat for soft robotics that are really crazy to see. Then there's hydraulics, which is another interesting way to make things move. Solenoids we're going to go into. They're totally an interesting category. They're what's at the core of every motor and probably the heart of every part of that. A solenoid is an interesting piece. Nylon muscles is another interesting one. And this one's relatively new to me. Turns out if you take fishing wire and you just coil it really tightly and then heat and cool it by having a heating element inside, it will expand and contract in interesting ways. So you can get linear motion that's sort of like a muscle fiber, which is really cool. And then memory wire is its own thing. There's a wire that you can heat up and cool down, and it will retain a shape and do interesting stuff. Then we're going to talk about relays, which is what's at the heart of what Ruby did. And then solid state relays are sort of like a newer version of those. Heaters in general are an interesting category. Power supplies I threw in here, and H-bridges I threw in. These are sort of like power management things more than an output necessarily, but worth it to know about for power distribution. And power supplies, I mean like a thing that you plug into the wall. It's worth it to think about the difference between a wall wart, like that your phone charger's in, or like a benchtop power supply or whatever, different from batteries. So those are always worth exploring if you're interested. Then there's H-bridges, which are good for controlling motors. On the audio video side, we're going to just sort of jump in with OLEDs and maybe e-ink, but there's also speakers and piezo transducers and video where you can fully output video from an Arduino, which is a little crazy, but you can if you really want to go down that coding game. So there's all sorts of different levels of things that you can explore. There's a more complete list also that we could play with. Whoop. So let's see, the hop in over
Corey,
here.
can I ask a question?
Take a look. So the first concept that we're going to get into, which will drive a lot of these different, yeah.
I was just wondering, at one point on the previous list, you mentioned relays relating to Ruby's project. Were you talking about the lamp project?
Yeah, sorry, yes, and probably we mentioned that before we started recording. Ruby, I'm really hopeful that you can hold up that lamp for us a little bit later if you've got it nearby to show us on Thursday this past week. Ruby did some cool stuff with a relay, turning like a regular desk lamp on and off on
different
mains
lamp.
voltage.
Yeah, not the cloud lamp. I like lamps.
Different lamp.
Okay, I just got confused.
Ruby is becoming our light master.
I was thinking the cloud lamps, and I was like, wouldn't that output be light? So I got a little lost there.
Yeah. No. Let's see. And a couple other questions. A cool use of nylon muscles. I'm not really sure about that one. I'm fascinated with the nylon muscles option for all of these different actuators. I've seen interesting, like very slow, subtle motion constructions. I'm imagining more like an art installation where you're just trying to get something to visually move more than like trying to lift up weights. So like getting paper cranes to flap would be really cool with nylon muscles if you could hide those somewhere in the crane so that they didn't look like there was a motor there. There's a ton of cool applications, I think. I just need to know more about them. I'll probably try and pick one this week. But pulse width modulation. This is a core piece that we're going to need to look at. And the main idea here is that Arduinos can't output analog voltages. So it turns out that it's really useful to be able to vary the voltage that you give to these outputs, but Arduinos just can't do it. They give you one of two states. They give you 5 volts or they give you 0 volts. And that's all. That's all they do. So they can fake it. They can fake giving you 2.5 volts or giving you 3 volts or giving you 1 volt by very cleverly turning on and off faster than you might imagine. So like just to put in the premise for what's going on, if you have a bunch of motors, basically the higher the voltage, the faster the motor will spin. And so if you've played around with motors and batteries as a kid, you might have plugged a motor into a battery and seen that it spun. Or I grew up in Ohio, really close to Cedar Point. So on a hot summer day, you'd buy like this little tiny fan that was a motor just attached to batteries with a switch. And you'd use it to like cool yourself off in the hot sun while waiting for a roller coaster. And like it worked great for an hour, and then the battery started to die and the little blade went slower and slower. And you knew, like, you weren't ever sure whether it was the cheap construction or the batteries dying that was making it stop. Turns out it's always the batteries. Like as the voltage drops, those motors would keep going, but as the voltage drops in those batteries, the motor gets slower and weaker and slower and weaker, which is interesting. So basically, if an Arduino wanted to control the speed of a motor, it would need to adjust voltages, which is a thing it can't do. It can only give it 5 volts or 0 volts, and that's all. But using pulse width modulation, you can do interesting things that sort of simulate that, or even by getting tied into your power supply, depending on how you hook up your circuit, you can supply 5 volts to a motor, or you can give it all the way to 0. But you've got all of this. You'll notice I stopped before I get to 0 on motors. Most of the time they have a certain minimum voltage they really need to do much of anything. And so they'll oftentimes stop if you give them too low of a voltage. It's good to have played around with the motor enough to know like what your cutoff is for it to not work. But it's a neat thing. This is also, PWM is something that we're going to use for motors this week. It also is how you do dimming in LEDs. LEDs, though, are a little different. They can turn on and off as fast as you want because their response time is super fast. Motors, though, have a spinny bit. And so if you blink power on and off to the motor, the key move here, and I'm going to head on to the next slide, the key piece is that if you blink power on and off faster than the motor can stop spinning, it's sort of like you're only giving it power some percentage of the time. So to point this out, let me find my cursor because I'm losing it on the multiple screens. Okay, my cursor is up here. So here's a good example. So if I do pulse width modulation, I can say I only want to power my motor 25% of the time. So I have this cycle. Pulse width modulation happens in a cycle. Those cycles happen at 490 hertz or 980 hertz. That part doesn't matter too much. It's just that it's faster than a motor can respond. But sort of a cycle goes from one green line to another green line. And if I'm pulse width modulating by doing the Arduino move analog right 64, that would mean that 25% of the time I apply 5 volts and 75% of the time I'm not applying 5 volts. So basically it gets power 25% of the time, 75% of the time it's off. So that would be like applying a voltage of 1/4 of 5 volts. So like, 1¼ volts. Or if I do a 75% duty cycle, this is turning the 5 volts on for 3/4 of the time and leaving it off for 1/4 of the time. So this is like only applying 3/4 of the 5 volts. So mental math, 3 3/4 of a volt, right, is essentially what you're simulating giving a motor or an output on that case. But this is basically just a system where you go through a cycle and you're imitating voltages. It's a good question. This trick is something that lets you play with dimming. So maybe, even though we're going to talk about motors, think about an LED, right? If I have my LED on for 100% of the time, so I analog write 255, that's a full brightness LED. It's always on. And if I have it completely off and I analog write 0, then it's just going to look like it's off. But if I analog write 127, then half of the time it's on and half of the time it's off. It's going to look like it's dimmer, but not off or all the way on. It gives me sort of an in-between. And so I can modulate the brightness by changing how much time it spends being turned on versus being turned off. And it turns out that for an LED, that deals with brightness. And so you can do the dimming effect that we've hopefully played around with a little bit. And if you built the Arduino shield that we designed and we soldered together, those definitely have you dimming things for RGB LEDs. But if you apply the exact same idea to a motor, it lets you go between what's 5 volts of full turned on and 0 volts of full off. So you can run them at half speed if you want, which is useful because then it lets you do some control things. For Arduino, your range from like off to on is 0 to 255, and that's just because it's an 8-bit system. But in a more general sense, we call this a duty cycle, which is kind of a fun, snickering middle schooler name for it. the duty cycle. And so in there, usually you refer to these in percentages. So I think on the Raspberry Pi GPIO 0 controller system, you do refer to it as a percentage. So like 25% would mean 25% of the time. Analog writing 75 would be 75% of the time. So different systems have their own conventions, but for Arduino, 100% on would be 255 and 100% off would be 0. There's only some pins on an Arduino that can do this because it is like an extra tricky piece. It has to have built in the circuitry to do the cycling. And so 11, 10, 9, 6, 5, and 3 can all do it. They need to have that little tilde that's right there to designate them as a PWM pin. And different versions of Arduino have more pins that can do it. But only those pins can analog write. So you've got to be a little mindful of that if you want to do some fading. But that's one of the ideas. It's going to be something that maybe will make sense when you see it applied. And so we'll take a look at what that looks like when we get a chance to play around with things. Also, it's definitely a stretch goal. When you get to have a motor, at some point, you're going to want to have it be on or off. On and off is the first thing, and then like partially on is the next step. So you'll get there. These 6 things that we're going to go through is, again, just to start. This exact slide was in the last one. I think I just changed it to, nope, didn't change a thing. We're going to go through 6 pieces. So the first of them is the brushed motor. A brushed motor is our very first player in this game. This is the simplest thing. A brushed motor, it wasn't done with brushes, but the very first motor was a Michael Faraday invention in England a long time ago. This is absolutely one of the major landmark brains in science in its Western tradition. So Michael Faraday had invented the motor. He used a bowl of mercury and a magnet and a few other things to make it happen. But we use brushes at this point. So in a brushed motor, you've got a few pieces. You've got permanent magnets that are on the side. You've got coils that are in there. And then you've got a commutator ring. And then the reason that they're called brushed is because there's these 2 little wipers that go on the side. And when you have a perfect storm combo of a commutator ring, which you can see right here, it's got a little piece of metal and a split down it. Those splits and brushes work so that you get power. You power those coils alternately so that they're always being pulled forward and made to rotate. The physics of that is a fascinating thing. It's just magnetism that makes a motor spin. So it's magnets. And if you, I don't know how much you know your pop music, but there are many songs that refer to magnets as just magic. And that's not true. I can go for a long time about what makes magnets work, but they're the heart of what makes motors go round. So we're going to sort of just breeze through that. In this case, if there's a coil, that's the electromagnet part. There's usually an electromagnet part and a permanent magnet part to a motor, almost always. And so in the case of a brushed motor, the electromagnet spins and the permanent magnets are fixed on the sides. Those stay stable on the housing, and the coils are what rotate because you need them to be making and breaking contact with the brushes. Another thing about brushed DC motors is that they always need to spin quickly in order to work. They spin with low torque, so they can't push a lot of force, but they can spin really fast. And so usually if you want to get torque out of a motor like this, you're going to need a gearbox to go from fast spinning to slower spinning. But by doing the trade-off in speed, you get a bunch of torque. And so there's these adorable little motors. These are like the size of a nickel. This motor right up here, and you can see it's a very exposed gearbox up at the front. I really like those ones. They're very nice. And so they work super well, and they give you all those different things that you need. These, though, I will say that you need to be conscious with these a little bit. That one of the things that a brushed motor is interesting about is that they take the most current when they're stalled, when they're stopped. So right as these things start and right as they end, they take the most power. Because basically, as it spins, it's constantly breaking and remaking that electrical connection. And so that's when they're spinning really fast, they're only sort of breaking and making that connection, and it's got little breaks or relaxation times. Whereas when it's stalled, it's just got a constant contact, and you'll have more power draw out of a stalled motor. It's part of why, if you've ever been in a house where there's a washing machine, and when you notice that the washing machine turns on, all the lights get a little dim. If you've been in a house that does that trick, it's because as the motor starts to spin on the washing machine, that's the instant that it takes the most power. And then the lights are normal when it's running. Has anybody else had that experience, or was it just my old Cleveland house? They put starter capacitors in washing machines to try and make that less pronounced. I had a really old washing machine back in Cleveland. Let's see. So those are brushed DC motors. Next up is a servo motor, and these are actually based around brushed DC motors also. Servo motors are fascinating, and we're gonna go hop over and take a look at one in just a second. But a hobby servo is a geared motor. So you can see that there's a brush motor down here in the circuit board. This is one that's kind of like deconstructed, and here's a blue one that's all put together. I actually really like these clear blue ones just because they give an idea of what's happening. You can see the motor inside here. There's a gear train across the top. There's usually a little potentiometer right here. These have a circuit board in their bottom that's keeping track of how much they've spun, and a potentiometer that can track how much it's rotated in one direction or the other. So these are actually motors that have some brains to them. They have a full, complete loop of feedback, and they're really useful in RC vehicles because they can move and hold like turning mechanisms or actuators. You can sort of imagine the flaps on a plane going up and down a little RC plane. If you can imagine interesting linkages that go between these motors and where they're headed. Let's see, if we hop over, I've also got one of these queued up. Yeah, no pop song about these ones, which is a little sad. Here's an example of one that I've got all hooked up in Tinkercad. So you can see the servo is up over here. This is a servo motor, and it's just got this servo horn. This is a really common way to go. Those holes are all there. So if you have like a little wire linkage to your flaps on an RC plane, those wires that connect them can be looped into those holes. But it just goes back and forth. And this is like the full range of motion for a servo. A lot of the time they don't have much torque. They don't have much push, but usually just enough, right? So they can play around, they can do these things. And there's a lot of different control conventions to these. So in here, you can see it's got values that I'm writing to it. So my code is just this right here. I want to go up by 1 from 0 to 180, and then from 180 down to 0. Here it's serial printing its position, and then here's a graph showing it live, which is really, I think, helpful to see that it's just going along. And when it hits the top of this position, you'll notice that as soon as that top hits the wall, it's going to stop and turn around and go the other way. These have, well, if there wasn't a delay, there is a delay apparently in the graphic and the graph. But the key is that it should just be able to rotate between 0 and 180. A servo motor like that, if you give it a command, it'll try and get to that position, and it'll try to stay there. So if it's holding up a flap and there's a pressure that's down on it, it'll keep trying to push it up because it's got feedback about its position. So these can be really helpful if you want a motor where you're saying, go to a position and stay there. It will do its very best to stay there. You can definitely overwhelm them, but it's a really interesting way to try and get some motion that's controlled. Early robot arms, for people who are trying to figure that out, are definitely built with servos. I've built many robot arms with servos with kids. They're totally a fascinating way to do it. Usually the heavier the arm, the beefier the servo you need though. But very, very interesting. There is, yeah, we'll have to play around with how you'd simulate a relay in Tinkercad. Let's see, we're gonna hop back over to here. Let's go back to presenting. And so servo motors, essentially they have 3 inputs: power, ground, and a data line. The data line is something that you have to choose a PWM pin for. They take a PWM input. Then there's stepper motors. Stepper motors are a different category of motor. These sort of fall, they're next door neighbors to brushless DLC motors. So they are a brushless DLC motor, but they're not meant to spin continuously. You can see those like teeth on them. Those represent the steps that are on a stepper motor. These are the the pieces that can move around finite amounts. Usually they're rated for a little bit more torque than the other motors. They're more complicated to drive. You usually need a stepper motor driver of some sort to make them go, but they can spin very precise amounts. So you can imagine the laser wanting to cut a line that's exactly 3 inches long. You can tell it some command and it will move to what is exactly 3 inches of motion. So that's absolutely something that's good to do. Or if you watch a 3D printer, usually, especially the, I'm like looking over at the Prusa. The Prusa's motors are very visible. So you can watch those motors spin just the right amount to do what you want them to do. There's no brushes, so the electrical coils stay still. It's the magnet bits that move. So it's flipped sort of from a brushed motor, and that might be why they get more torque. They come in lots of different sizes. There's these little ones. Any inkjet printer you've ever used, they had stepper motors inside to designate all the motion that the inkjet head needs to do. But then these are NEMA 17 motors that have this sort of square, or NEMA motors. They have that square profile. NEMA is like a screw hole dimension so that you know exactly how to mount them. I think it's 17 millimeters across diagonally for a NEMA 17 motor, which is the standard size for most 3D printers. Solenoids then are fascinating. So at the core of pretty much all of these, and if you've been looking, there's been coils of wire everywhere. Solenoids are probably worth a deeper dive just on their own. As a concept in general, there's a lot that's going on here. This is an entire half of a chapter in my physics classes. Solenoids themselves merit their own like section of a book because they're interesting things. It turns out that one of the pieces we haven't talked about much because it hasn't been relevant is that if you pass electricity through a wire, it makes a magnetic field. And so if you have a wire that's carrying a current, like if you have a wire that maybe is this remote up here, there's a magnetic field built as a circle around it. And solenoids take use of that. And if you take a wire and you wrap it, since it's a circle and another circle, a coil actually takes that and it amplifies the effect of the magnetic field around a wire, but only inside the coil, essentially. So you can see this diagram here across the top has got a bunch of black arrows that represent a magnetic field that's really strong inside, and those arrows spread out quite a bit when you're outside of the coil. Or this diagram over here, sort of the black and white lines, those stripes are showing you sort of the field perturbations that come from the solenoid, and then they get way more dispersed on the outside. Basically, it means that a solenoid has really got a strong field in the middle, and it only happens when electricity flows through the coil. So this is the essential electromagnet, right? And so this is when you put electricity through the coil, it makes it a magnet, and when you turn off the electricity, it stops being a magnet. It's very handy to have this as a tool. You can imagine those big like car lifting magnets in a junkyard. Those are electromagnets, right? They're able to turn on, pick up a car, and then when they're over the place where they want to let them go, they just drop it. And so it can drop the car into the compactor. So being able to turn magnets on and off is really helpful. And solenoids are the coil of wire that lets you do that. If you wrap them around like a solid or like a series of layers for a core, they can be good at being just a magnet. So transformers often do that for electromagnets. But solenoids are another interesting, solenoid is the name for the coil itself. But a lot of the time they've become commonly associated with doorbells and cars. And so solenoid valves is where they show up in cars, and in pneumatics, and solenoids in doorbells. If you've ever had a doorbell with an actual bell, the thing that taps the bell is a solenoid. It's got this little plunger. I've got this diagram right here that's moving a little bit. It's got a plunger with a spring. When it's not powered, the spring is going to push this plunger over here. That's how I know that that's the direction it is when it's off. And when you power this coil through the blue and the red line, it's an electromagnet that pulls this perhaps magnetized piece of blue metal in through, and you've got this green actuator that comes through and maybe pushes a button on that side. It sounds like a weird thing, but here's a lovely application of them. I hope that the sound sort of works. Let's see if we pull this up on YouTube. Maybe the sound may not, we'll see. playing Jingle Bells. Volume. So they're going to swing around and get really close to this so that you can see it. Yep. That's totally, they're irrigation valves, they're little musical xylophones, they're all sorts of things. It's a really cool, let's get out of here, head back over to our slides. Okay, there's a ton of really, and kudos to whoever made that. It's awesome. Totally worth seeing that. A solenoid is really good at moving just a little piece of metal a short distance. And basically that's it. So if that's connected, if it's going to hit a xylophone tube or a copper tube, you can make music with it. If it's got a valve for air, for compressed air in a pneumatic valve, a pneumatic solenoid, then you can turn things on and off with a solenoid valve for irrigation. Same deal with a valve to open or close a valve instead of needing to turn a knob to get a valve to work. There's a ton of different applications to solenoids, but they're interesting ways. They're really limited in their throw. Don't think this is going to push something 6 inches, but if you need to move it 1/6 of an inch, then perfect for a solenoid. Or if you just need to tap something to make it happen, it's a great way to go. It's why doorbells work really well, because you're really just tapping on the bell, right? You're just sort of giving it a little tap so that it rings, and that's all you're wanting to do. Yeah, Kate, thank you for putting in the chat if you wanted to hear it. It's a charming little xylophone. So there's a ton of interesting things to consider with that.
So Corey, you could make one of those and basically program different songs, right? Like that.
Yeah, absolutely. Because you just have like, imagine a mallet for each note, and you can decide when and how often you want to hit them. You could play whatever. You could even tune it into a keyboard. So if you wanted a keyboard xylophone, you could totally do that. So you could just sort of swap modes between different things. You can do a lot with it. Down over here, one of the things about these, so they're sort of raw and unabridged power consumers. There's all sorts of different sizes, by the way. Those were handmade ones, and it looked like instead of a spring, it was just gravity pulling the bolts back down into the tube. So when they were done being activated, they would just fall back in, which is probably a clever way to do that. These ones here would be sort of the doorbell kind of solenoids where there's springs on the back end, and then these actuators that might move something. Or you can even just make them regular old coils. Solenoids like this are also what's at the core of making a speaker. So if you want to build your own speaker from scratch, and there are absolutely companies that do that, they charge like 10 grand per handmade speaker. Very large amounts of money for boutique speakers. You can totally do that if you want. I'll put a link in the chat for a styrofoam plate speaker that I really enjoy. The tricky part is you need a solid neodymium magnet. I literally just found one in MakeHaven here today. So, if you've got a solid neodymium supply, you can make your own speakers. But the circuit for solenoids are fascinating. Their symbol is just a coil or just like a series of loops. And so you've got this, a transistor to turn them on and off, and then you can run them at whatever voltage your supply is. So you don't need to power them directly from the Arduino. It's probably actually better if you don't power them directly from the Arduino, because they can pull a bunch of power, and then because they're sort of raw electronics pieces, they also will do something when they turn off. One of the things about a coil of wire is that it wants to keep the current the same all the time. And so when you go to turn them off, they actually sort of don't like it. If you're willing to give me the latitude to personify them, they don't like a change in flux. So they'll induce a back EMF, and putting a flyback diode on them like this, sort of like LEDs or light up diodes. There's also ones that don't light up. This diode right here gives that back EMF a place to go. That when these want to make a spike that could fry an Arduino, they probably won't. But if you're worried about it, you can apply a diode like this, gives the solenoid a safe place to dump that current back. This is totally a good move to have in here. And then transistors like this, I think we tried to order a few of those. So there should be some transistors which are electronically controlled switches. Another output that's interesting in its own right. And so these, your Arduino can control whether the solenoid is on or off. And we can definitely go into this more. I feel like this is going to be another one where I'll make a circuit video about it this week. If you're interested in solenoids, this is the like quick and dirtiest way to run them, but there's lots of options. So I'll make a video very soon about how the details of how current builds and flows through a circuit like this, because it's fascinating. But oh, I just kind of want to play that little thing again. Next slide. Okay, so next up, we're going to talk about relays. But before we do, I just want to say safety is essential as you're doing all of our things. We've talked about sort of the core of foundations. There's not a lot of rules, but we say don't make your own parachutes, don't build your own life support systems. And when you're dealing with mains voltage, also be careful because it can zap. I've been shocked many times. You probably will have more of a bad day than a real problematic thing, but it doesn't take a whole lot of current, especially if it can get under the skin, to be a big problem. And so your skin is very resistive, but then everything inside the skin is basically a big bag of water. So be mindful of that as you're thinking about circuits. I would never condone putting electrodes inside your body in any way. That said, we're going to talk about relays, which don't do any of that. It's a perfectly safe way to handle switching of mains voltage with an Arduino. So here's relays. You can see laid bare the coils that are in them. These are solenoids, absolutely. And basically all they are is a solenoid activated by an Arduino, in our case, and activated by an Arduino. But it's a solenoid that doesn't take a whole lot to make happen. But when you do that, instead of going up and hitting a xylophone tube, instead it flips a little switch. And I love this GIF. When you turn on the solenoid, it pulls this little lever, which sort of jimmies around and then pushes these two contacts together. So this little teeny tiny battery, you can sort of see the analogy, is able to control this larger battery, this larger circuit, without really being in direct electrical contact. So you can switch on and off high power things with relatively low power circuits. Here's a good example of a diagram for how you do that. The flyback diode makes a lovely reappearance, another transistor to control your solenoid. And then here's AC power that's switched on the other side of the relay, not touching the Arduino at all. You definitely want to make sure you know your pinouts on a relay or on a relay board. But these are pretty accessible and pretty easy to implement. So if you want an Arduino that can see if it's dark out and then turn on a light if it's dark, or if you want to have it turn on a full lamp when it's dim, relays are the way to go. So that you can have lights that flicker in any sort of way, or if you want to switch on and off full like strings of Christmas lights. If that's your game, if you want to really knock it out of the park for the holidays, you can absolutely hook up a whole series of relays. I helped a kid, oh God, it was like 5-6 years ago now, whose dad was very into holiday decorations. And so we got a board that would listen to music and break it up into 8 channels, and then it could switch relays off and on to turn the lights on the house on and off with music. So it was a really cool, like, completely made with Arduino and like goofy little solid state relays to turn things on and off. It's totally doable. One tricky thing about these guys is that because there's a mechanical switch that's flipping, you really can't pulse width modulate them. They just can't switch fast enough, right? In order to pulse width modulate, you need to be able to turn on and off power at 490 or 980 cycles per second. And these take like maximum speed 10 cycles a second, right? So these are more like on or off kinds of devices. You're not going to use these to really dim a main light bulb. If you want to do that, you want to look up what a triac is, because that will do it. But these are going to be just on or off, sort of the binary situation here. Solid state relays just don't have any moving parts inside. They're definitely more newfangled, but interesting. There's a whole pile of relays in the back room MakeHaven of relays. So if you wanted to tear one apart, look at what it looks like, play with the little switch to see how it activates, you can totally do that. They have all kinds of ratings and they're really cool. A couple questions coming up. Back EMF is totally a good question. Back EMF is a fascinating thing. It's a back electromotive force. So it's a voltage that gets when a coil, like in a relay or in a solenoid, when you stop putting current through it, in order to try and maintain its magnetic field, because really it wants its amount of magnetic field to stay constant, it will induce a voltage in itself, like as it's fizzling out. It's a weird quirk of how electric charges move and things, but you get a backwards voltage that these flyback diodes are letting dissipate instead of going back into your Arduino. And so I'll try and explain that a little bit more with a video. It's a goofy thing, but it's electromotive force, which is another word for voltage, because we need 15 words for it, apparently. Let's see. Any difficulty to analog systems of PWM? Good question. So for PWM, like on a relay, PWM has to switch very, very quickly. And so you can't, if your device can't switch quickly enough, you can't do PWM with it. Relays are the example of that. And yeah, they just don't have mechanically, they can't go fast enough. So a mechanical switch, even though it can be a quick switch, like keyboard or gamers will talk about their mechanical keyboards and how fast the switches are. But when they're doing that, they're just talking about the fact that they can click it fast. But fast for a person's finger is orders of magnitude different than fast for electronics, right? I can have a transistor switch on and off in milliseconds or even microseconds. And if you look at the data sheet for a lot of things like a transistor or a MOSFET, they actually describe their switching time. And so you'll get like things that are 1,000 times faster than a relay switching time, which really is at the heart of how a lot of digital electronics have been major upgrades from analog. But relays like this totally work. Like the old controllers in an old car, they would have little digital or analog electronic control systems. And then a relay would be what tips on the starter motor, right? They don't want the control electronics to be actually pushing energy from the car battery to the starter motor, because it takes a lot. It starts stalled. So it takes the most current to get it started. So they'd use a relay to go from the control electronics to the starter motor direct from the battery in order to make that happen. It's a fascinating thing to see sort of how this all fits together. But relays have been ubiquitous in electronics for a long time. And so they're definitely something that are worth taking a look at. When you're playing with these, just be careful and mindful of the AC voltages. They're probably going to be on the screw terminal side. Just keep your fingers away from that. You're going to be okay as long as you're not bridging that gap with your fingers at any point. And then the last one of our 6 major outputs are OLEDs. OLEDs are fascinating. And then there's all sorts of other displays, LCDs, e-ink, sort of pixel matrix things. There's tons of different options. I've played with every one of these 4 that are depicted. 16:2 LCDs and OLEDs and e-ink and pixels. These are each cool. The e-ink is like an e-reader where it displays something on screen. These are really cool for low power applications or if you're going to be in sunlight, because they only take power when changing what's on screen. They don't need powered otherwise. So if you want to have like a standby, it's why the Kindle can stay alive for so very long. You don't have to have it powered unless it's changing its screen. These OLEDs are really neat. They emit their own light, so they have perfect blacks and nice bright colors. LCDs are tricky. You can get them with backlights or you can get them without them. And then these pixel displays are cool. Those, like writ large, are how stadiums do their lighting systems. Also, fun side note, the Super Bowl was yesterday, and I kept looking at the edges of those buildings during the halftime show, thinking those are definitely LED tubes. Absolutely, to decorate the sides of those buildings that they had. So these displays are fascinating, really a great way to add some detail to a project, but they also are tricky to run because you need to either command each pixel or write in characters. And so libraries are going to be the trick that you need to make these work. And so we're going to circle back to libraries in a minute, but there'll absolutely be a library from Adafruit for each one of these displays. I think these 2 are direct from Adafruit. There's just a ton of them. So lots of people have written libraries that you need to make this happen. And it's really a fascinating way to add some information output to any project. So how do you control a motor? We talked a lot about motors. Servos are the easiest. They have their own built-in motor controllers, but everybody else is going to need to have something. Most of the time when you have a motor, you want it to be able to spin in 2 directions. The simplest is sort of the circuit with a transistor, but the H bridge is the classic iconic way to drive a motor so you can get 2-direction motion out of it. And you can do it with just a set of switches. All you need is 4 switches. So if you've got power that's applied here on the input, that power can be routed. If I close switch 3 and switch 2, I go through this magenta path. And if that's forward for the motor, I can instead leave those open and close switch 1 and switch 4. And current passes the other way through the bridge of the H. And then it runs backwards, right? And I don't know which one would be forward or backwards, but you can get it to pass through that motor in opposite directions, which would let you run that motor forward or backwards. This is such a big deal that, like, not only is it useful in the useless box or in other interesting places, this is essentially the control structure that gets built in for just about every DC motor. You want to have an H bridge, and the level of detail or control you can have for that is really what drives it. This is also sort of the first version of what gets used for stepper motors and for brushless motors and all those things. They're all based on this H bridge architecture, where closing the right combo of switches makes things work. These are sort of more what a diagram would look like for a chip if you had a chip-based system. And you've got P and N channel MOSFETs and some diodes and other things to make this work. But there's all, you can stare at this for a long time. This is probably another one that's worth it to make a diagram for. Although there's a bunch of really good explanations for H bridges online. I'll link to some in the Foundations channel after this. So if you have an H bridge, building one by hand is a lot of fun, probably worth doing with a switch if you have a DP-DT switch. But motor controllers are probably the next best step. And so motor controllers like this, here's the simplest one with just a single transistor. This lets you be on or off. It's got a flyback diode to handle a back EMF and everything that you need just to drive it forward, but it would not turn around. If you've got an L298, this is the classic, probably the oldest one of, maybe not the oldest, but one of the older chips that will drive a motor. These little motor controller boards are really helpful. You can plug in a motor here, you can plug in a motor there, and then put in your power. And then all you need to do is put in signal for if you want it to go and if you want a speed control and some of those things. You put in on a couple pins over here, but this handles lots of the logistics for you. There's some current regulation, capacitors to smooth things out, to deal with the stall current, and lots of different pieces. Then there's more interesting ones. This is good for handling 2 brush motors or maybe 1 stepper motor. These are what's commonly on a 3D printer. These are smaller chips made by Texas Instruments, and they're good for driving. This is a good convention for a stepper motor where you have a series of coils put together. Maybe even, this might even be like a, yeah. And so in here, you've got a microcontroller that can tell it, would you like it to reset the stepper motor or the motor controller? Would you like to put it in sleep mode to save some energy? Or would you like it to go a certain number of steps and what direction? So just 2 pieces of information. Like you give it a pulse every time you want it to make a step, and then you either write it high for forward or low for backward on the direction pin. This is often handled by a library, so you don't need to know the logistics of it. But little stepper drivers like this are really, really helpful. They let you drive motors either forward and backwards or drive steppers with very precise step control. So they're totally cool pieces to have control. And the fancier, newer chips of these give you like feedback, so your system can tell if the motor is stalled, or you can tell if it's drawing more current than it's supposed to be doing. There's all sorts of weird sensors and things that get baked into the brand newest ones of these. The newer the controllers, the more surface mount they are. And so you can see that this is a surface mount chip, which just means it's so small that it would be hard to put into a breadboard. And then there's little pins so that you can stick it into Arduino-based circuits from there. We're going to work our way up to surface mount chips and how you will do surface mount electronics, hopefully. Fingers crossed. I'm working on trying to mill a surface mount circuit board at MakeHaven. And then that will be a thing that we'll be able to get to do in the future. So how do you control all these things? We didn't really talk much about code other than a quick mention for how that could go. This is where we're going to start in with how to do things. So there's libraries abound on these outputs, whether it's for stepper motors. There's a stepper motor library built into Arduino. I think the 16:2 LCD also has a built-in library for Arduino, but then there's which I think is called Liquid Crystal. And then there are lots and lots of other different libraries that you might need to run an OLED, or to run maybe steppers in another instance, or to run solenoids exactly how you'd like. There's a lot of different places and ways that you can run these things, and libraries are going to help you do that. The Servo library is built into Arduino, and so Servo Sweep, if you go to File Examples Servo Sweep, which is, I've just memorized that at this point, you can use the standard Servo library, and here's your 30 lines of code that'll get your servo to go back and forth. I've just recreated it in Tinkercad, made it into a GIF. And so here's this servo moving back and forth. It's sliding along, and all of this is handled by a library. There's some logistics to how you tell a servo, I'd like you to go to position 173, please. But the good news is the library deals with all of that for you, so you don't need to learn the exact mechanics for what % of your time, what % of the pulse width modulation signal time you have to use to get it to a certain position. An Arduino library will handle that for you, and the same is true if you're using Raspberry Pi to drive servos. There's lots of different libraries that will handle the logistics on the very lowest level for you. If you're interested in that, you absolutely can learn those pieces or read this header file to see what they did to make that happen. There's no reason to. For a long time, you're going to have all of the control you need if you just play around with this. Like in this particular example, they use include the servo library. They declare a servo, cleverly named my servo. Then my servo, they say, is going to be attached on pin 9. And then for position 0, less than position 180, you'll go through this loop of writing the position of the servo and waiting for 15 milliseconds. And you do that as you move from position 0 up to 180. And then once you hit 180, it exits this for loop and goes on to another for loop that goes from 180 back down to 0, waiting 15 milliseconds each time. So this is a nice way to control a servo, and you don't need to know the logistics of when or how it's doing all of that. It's handled in a library with some object-oriented programming behind the scenes for you, which is great. Essentially, there's a library like this for just about every one of these outputs, and so finding the right one for your particular thing is perhaps the trick that comes first. And so there's Servo for servos, Liquid Crystal for 16:2 displays, and lots of different other examples to look for. So what is the next step? Output something. That's the goal for this week, is just to try and output anything, whether it's to try and include some motion, whether it is to try and display something. There's lots of opportunity for how you can output things. And so your goal is to hopefully try and do just that, to try and get your Arduino controlled systems to make something happen. This is the very core of what's going on. And so if you wanted to, you can make, this is the core strategy that makes all of the different things that we're working on. I just today read an article about somebody at MIT who put together a machine that is part of they've added onto a laser cutter that also has a pick and place, and it also has a little extruder that'll pneumatically push some solder paste on so that you can put in a design and it will laser cut and print you a circuit board. It'll even pick and place components in and solder it for you, which is crazy town. But essentially, it's just a collection of outputs and some really clever coding that make all of that happen. And so the goal for you is not to try and do anything that ornate at all, but just to try a new output. If you haven't made something move yet so far, playing with a servo is going to be really exciting. To get to see a servo move or to hear a relay click for the first time is going to be a very exciting thing to watch happen, especially if you can get it to turn on a lamp or to make something else go. There's a ton of really cool opportunities to make these sorts of things useful. And so we're gonna get there. Let's see, we're pretty much at it for time. One of the things, I was working with Kate earlier Ooh, a good place for sample or starter projects. My strong suggestion would be, let's see, I'm going to pull up Arduino. A really good one to play with at the beginning. Ooh, not what I wanted. Trying to pull up the Arduino IDE. A good place to start would be to find a servo and get it to move. So once Arduino opens, let's drag this up to here. There we go. Nice and big. In here, if you go to File and Examples, servo will be, there's stepper right here. So if you want to have a stepper, just do 1 revolution. There's an example code that'll just do that. Here's liquid crystals. So if you'd like it to blink or display hello world, these are really good places to just get those things connected, coded to make that happen. And somewhere down in here, I'll have a servo library. There we go. Servo sweep. Servos are really great. There's 3 connections. They work really reliably. And as I think that we have hopefully gotten a few servos ordered. So you should just be able to plug them in with 3 wires to your Arduino, and then the whole thing will just happen. It's fascinating. And then you can play around with how much they move. Where do they go? Like if you don't want it to go all the way to 180, you can change that number and make it move in all the ways that you want it to, or make it do a funny little dance. Can be lots of fun. I've even, if you get 4 servos, you can make them like little legs on a tiny table, so that you've got a little robot that will sort of walk its way across the tabletop. Is fun. Or if you just wanted to like do a little cha-cha, right? It's totally a fun thing to do. I have done it several times and would strongly encourage. So absolutely start to play around with different things. I think motion is going to be the name of the game. So we've hopefully ordered, and maybe they're even here, some servos, some steppers, some things for you to play with this week. That would be absolutely my suggestion. And just start from the examples and then fiddle around with the code from there. So with that, I want to stop sharing and see if anybody's got any ideas, thoughts, questions, where we're at. Let's see for this. I can do, oh, it's going to record anyways. Yeah. Okay. And so, yeah, any questions, thoughts, ideas? Anybody immediately struck with what they want to do?
Well, now I'm rethinking things. I wanted to do something with a sound input, because we have some problems in my house with the sound levels, and
Sure.
I wanted to try to make that into a visual for some of the smaller people in the house.
That makes sense.
But now I'm curious. See, there's your sound level. Good job. But now I think I'm curious about motors too. So.
Mm-hmm. Well, and you could even do a sound sensor and then like a little flag that gets raised, right? A servo that's like, nah, that's the first flag.
A red flag, like in a
yeah, a little red flag. That'd be fun.
The first one puts up a yellow card, and then the second is a red card. And then the timeout box door opens, and it's soundproofed.
Yeah. There's tons of fun options there. Wagata, you're unmuted. Do you have an idea what you want to try?
Yeah, I think I'm going with I ordered a bunch of stuff over SparkFun. So I got these grippers that kind of look like those beetle pincers.
Oh yeah, those are I played with those. They're cool.
Yeah. And then there's another one that looks like a cell phone grip or something. That does it through servo as well.
Yeah.
So I'm gonna try a couple of different things.
Yeah, those servo-based grippers are really great because they'll move, and then because a servo wants to hold the position that you've got, it'll grab it and like try to hold a thing. So you could grab like a piece of celery or something and like hold on to it, carry it around.
Yeah, they're suggesting like having a camera on there that can move automatically, because I guess it has 2 degrees of freedom on there.
Yeah, if you have
but I don't plan on doing that. But
yeah, like if you can rotate this way and you can rotate this way, now you can do a lot of motion things. Not that that's a great example of a gimbal, but like a two a 2 degree of freedom system is really cool.
Yeah, looking forward to that.
Cool. Anybody else have fresh ideas or questions or things?
So, as you all know, I'm really big into home automation, and I frequently on Reddit see these people that make like automatic door openers for their like dogs or cats if they're outdoor cats. And I'd love just to be able to like know how to get a motor to open or close something. I think like that would be an area that would be of great interest for me. Uh, so I think that might be an interesting thing to do, or maybe like something with a pump of some kind. Like I want to very soon I'm going to start planning a lot of like lettuce and various other things for eating, and I think it'd be kind of fun to like figure out a way to irrigate that in a way. So
Yeah, that sounds cool. Solenoid valves would be great for irrigation. Thinking about my mind started spinning about the door. One of the things that is, so a lot of people will just be like, let's add a motor to it and it'll work. One of the things that's absolutely true, we've all experienced very heavy doors and like light as a feather doors. If you want to move a door with a motor, it'll be much easier if you start off with a well-balanced door. Or like if you want to be able to open a door and specifically only open it and it already kind of wants to open on its own, but the latch is good at keeping it shut. If you can just release the latch and the door will kind of swing open on its own, that's a great move.
there is a third door, no pun intended, and this one's actually inspired by Kate. So I have this thing that I use to fold shirts, right? And if it makes it really, really easy to fold shirts, but if I could somehow like push a button and a series of like motors and pulleys could automatically fold it, like I'd be delivered. I think that would be the best. Yeah.
I kind of sometimes wonder what's the border between automation and our regular life. Pretty soon we're all going to be pretty useless.
Yeah, I just saw a robot toilet cleaner. That sounds great.
Now you know the necessities of life: a laundry folding machine, food, water, shelter.
What was that?
Eliza thinks that would be added to her necessity list, right up with food, water, shelter. The laundry folding machine would make her life much better.
I blame Marie Kondo. It's all her fault.
Yep. All right. So let's it sounds like we've got some good ideas for this week. Things that move are always very exciting. And so again, don't try and solve all the world's problems with trying to get things to move or to power up. Definitely just try and do meager little motions. And then once you've done that, then you can tack on other interesting things. Just try and do some hello world stuff. Don't try and get to the craziest things right out of the gate. So that said, there's probably all sorts of things that may have been crazy, that may have been just meager hello world items that could have happened this week. And so we should absolutely show and tell to see what's been going on, what has been happening. And the Lego gift wrap machine is a good video. That was put into the Foundations. Was that in the Foundations chat or was it somewhere else? Let's see if we can find. Yeah, I'll if somebody starts with show and tell, I'll go find it in the chat and drop it from Foundations into here so that it can stay with the group. So first up, whoever unmutes.
I'll go.
Yeah.
All right. So this week in my crazy little world, okay, so this was like kind of my wheelhouse, but in a lot of ways it wasn't. And I've been chipping away very, very slowly on using a Node MCU, which is it's like a really tiny little Arduino board that has a Wi-Fi chip in it. To be able to, I've been wanting to make my own sensors for a really long time. I've mentioned it a few times, and this week I actually did it. So that's cool. But there's almost always a caveat. I didn't actually finish. So but I got really, really close. And I think I'm just going to like quickly walk through where I got. So first and foremost, this guide is what I've been using. Kudos to Corey for helping me sift through like what actually makes sense. But basically the idea is to take a little DHT11 humidity and temp sensor, plug it into this Node MCU board, and get that to wirelessly communicate to my Home Assistant platform so I can effectively make my own temperature and humidity sensor and put it anywhere in the house or move it around if I want to. And these instructions were pretty good. There's a lot of I wish I could say this as well as Kate does, but like ambiguities that are just like, what are you talking about? You should have used like 2 more sentences to describe what you actually meant. But in essence, what I did is I installed this ESP Home, which I've seen, but has always been like, okay, that's black belt stuff. I'm not ready for it yet. And now this whole world is opened up where like I can connect everything to my Home Assistant and not need to use like Alexa's protocols or like other things that are maybe privacy question mark. So this is like a game changer for me. So basically I put this in here, and I went through all the steps, and I noticed that like it's working. That is, it connects, but the sensor itself is returning. What did you say, Corey? A nan was? I always assumed it was a null value. It is, but it stands for something.
Nan is a specific, and I know JavaScript uses it, but it means not a number.
I love it. Okay.
Yeah.
Not a number. So in this case, like it's weird because it was essentially saying like, hey, I did great. I connected. I put in all this stuff, you know, etc. I don't want to show you my Wi-Fi password, but like, you know, it works. And then I was like, okay, well, the problem is that I wasn't able to actually find it. It wasn't showing up in my list of entities that is like registered devices that essentially can be queried. But then after some trial and error and following the instructions a few times over, it ultimately showed up. So this is the ESP Node MCU device that's being registered on my network. And then these are the 2 sensors. Like they're actually there. It created them, but it's not actually registering any values as we saw in the log. So now I essentially I have it connected. I understand that it's essentially working properly. It's just not measuring anything. So I'm going to try using a couple of different cables, trying a different DHT11 sensor, maybe taking a simpler approach to how I want to sort of figure out. I want to check off the easy boxes first before I do anything too crazy. But yeah, this is big. Just to summarize, once I figure this out, I could probably hook up any, like literally any sensor to any like Node MCU, and then be able to integrate that into my Home Assistant. So yeah, thank you, Corey.
Yeah, it's super exciting. I'm really happy for you to see like what is going to come next. One of the things that and it's neat. This was a Docker container that you put in, I think, for the ESP.
I didn't actually use the Docker container, and that's a great clarification. So the instructions recommend using Docker. I haven't figured out Docker really yet. Like I've used it in a couple of other projects, but I need a lot of hand holding. I hope to learn more like Docker code and how it works. If that's ever part of the equation here, like I would be amped.
Yeah.
But yeah, like I think Docker is obviously, well, maybe not so obviously, incredibly useful for everyone. No need to have to worry about having the right version or installing the right thing. It'll just work. So
yeah, Kate has probably got more experience with Docker than you or I. I understand Docker on a high level and have like wandered through some tutorials, but it's on my list of things to learn over spring break because it is on our slate for where we're headed. It's one of the networking pieces that I want to make sure that we're able to do because it basically it lets you run computer programs sort of like independent of the computer part, right? You need a
Well
computer, but
said.
it doesn't matter what computer it is. It abstracts away all the weirdness of like, oh, it's a Windows or it's a Linux or it's a Mac thing. It does some of that for you.
Yeah, like I have used I've used Docker on my NAS server, but like only following guides and being lucky enough to be like, okay, this is easy. Like
Yeah.
having to be able to think critically about it is a bit more challenging.
It's a different level. But beyond that, I think one of the things that's really interesting about this particular setup is that you went with the DHT, which is a sensor that definitely I've used a library for before. And I know that they have an output that needs to, like they're outputting two pieces of information. They're putting the temperature and the humidity out, and they give you those two data points. I think that what would be interesting as the next step for you is to try and step it down to like a light sensor instead. So
Yeah.
it's just a photoresistor so that it's just reading an analog voltage. It's not trying to decode anything. It's not possible that it's a communication hiccup, that it would just be like a simple analog read on the ESP82's side.
So if I was just to plug it in and get the right pin set up, I should be able to just register it as a sensor.
Yep.
And I'll give that a try.
Yeah, and it might be, it's been a long time since I've gone into the very lowest level stuff for how the DHT outputs its information, but if there's any like ones and zeros transferred back and forth instead of an analog voltage, it's probably going to be a more prone to any hiccups. Would be a little trickier. That's my guess. So.
And then the other thing that I just wanted to quickly say is that I'm probably going to try doing this with Docker. I wonder if like if maybe if this might be a good opportunity for me to take a stab at it essentially. So
Yeah, it totally could be because you've got your ESP home. You just need to keep track of whether your home automation system is connected to Docker, the Docker version of ESP home, or the like locally installed ESP home. And so you'll have to keep in mind who's going where for that.
cool.
Which is probably pretty abstract.
Yeah, getting there.
Yep.
Cool.
Awesome. That is a very, you went after a complicated one this week.
Yeah, I have that as a problem. You know, I'm like,
Yep.
oh, this will be easy. And then if it is easy, of course, I make it more complicated. But
yeah, it's all right. It happens to everybody. Many times. All right, let's see who's next. Wagata, you're unmuted.
Sure. I tried this I2C communication system, communicating one Arduino to another. So I have the Uno set as the master, and I have Arduino Micro here as a slave unit. Maybe better names could be used. So
Node is the new like favorites. That's the main, and Node might be the new.
yeah, maybe they'll change it like GitHub did.
Yeah.
For this I2C, I set up. It needs a pull-up resistor for the two lines that go. It uses a real-time clock to communicate between the two. And so I have these two resistors going to, I can't tell what pins these are. But anyways, for this setup, I followed a tutorial that has the light frequency blinking changing based on the potentiometer here, but I made a few modifications. So I push this button, and you see it lights up there. I think it's like, I don't know, something 100 or whatever as the analog output. And then as I turn the potentiometer, you'll see that it blinks a bit faster. So if I let go of the button, it cuts the circuit. Then push it again, it holds on. There's a photoresistor here, but you can't really tell, how much brighter it gets and stuff. So Yeah, so that's what I made.
That's awesome. Was that build all in one shot, or was it just like, I'm gonna try this, and then I'm gonna try this, and then I'm gonna try this?
Well, I started, on it, and then I got hooked on it. I just kept modifying it, building it, and trying different stuff. It was yeah, I don't know how much time passed. It was a Saturday, so yeah, but
Good.
it was, yeah, it was fun to build. So
That's cool. Yeah, those are great little like, what can I add now? What can I add now? Like continuing to spin it up is a lot of fun. It's a great. We're gonna have some snowy days this week. It'd be a good snowy day activity if you're looking for things.
yeah.
So that's awesome. Way to go. All right, Ruby, you were unmuted. You wanna go?
Hi guys. I'm so close. I am so close to finishing. I wanted to make a lamp that turns on when it's like low, like no light out. And I'm just waiting on some Arduino Nano, like mini Arduinos that I forgot to order last week. But I was able to get a test running with Corey last week, and I have those videos here, and I'll show you this like little diagram that Corey wrote for me, and it's basically my master plan that I've been just memorizing, because it's essentially like kind of the same thing that I'll be doing with my cloud. But I mean, what I didn't really think about like was that I've been using like solely like the breadboards for these tests, but when it comes to the perf board, it's not exactly the same setup, and like I knew that, but like I didn't really pay that any attention until it's actually time to solder the pieces in, and to remember that the rows aren't like directly connected to each other. And if you wanted to have that to like in that same sense as when you're using the breadboard, you're gonna have to like make a solder like bridge or wall or whatever. So that was cute to realize. And I'll show you the videos that I have.
They do sell perf boards that are exactly the same layout as a breadboard. They just like they cost more because
and it's like a non-necessary, you know.
Right.
Like I totally get why like these breadboards are like made the way they are, because they're really convenient to be able to use really quickly. But learning this, like actually acknowledging this, was a good realization for me this week, I guess.
Yeah, good.
So not that.
Yeah, the xylophone.
So the volume. So Arduino is connected. There's ground, there's a 5-volt, there's A0, and then I use D10, and there's the relay. That one is 2-channel, but the one that I ordered was 1-channel. Oh, and then where is this one? I think this is the same one. Is it the same one? It's basically, yeah. Okay, it's this one. Let me turn this off. Okay. So with the help of Corey and the assistance of Jamie, yeah. It happened really fast, and I was kind of taken aback by that, because I didn't, it's not that it's overly complicated. Corey kind of explained to me and broke down like how exactly they're connected, and I can see that through like this map, but I can also see it like physically, like through these parts. I just wasn't expecting that it would be so like how do I say this, like black and white, you know, if that makes sense.
Yeah,
I don't know.
play
I'm
the
used
video
to
again
like, how do I
if you
stop?
can. Sorry, it was a question in the chat. Please play the video. Oh, can you show us the video again, Ruby?
Hello.
Hello, hello. Can you hear us?
Yes.
Can you show the video again? Lila
Yeah.
wanted to see. And it's just neat.
Good.
Yeah, I'm. It's always exciting to see like how well it works, and that's Jamie just sticking their hand over the light sensor, so when it gets dark enough, it turns on the lamp with the relay. One of the things you probably don't want to, I get, don't play the sound. We're just sort of chatting about in the video, but you can hear it click. Like that was sort of a magical thing. It took us, I don't know, less than 10 minutes to get it to click, right?
Yeah.
And that's the black and white that you're talking about, right?
Yeah. I guess like I was expecting it to be more conceptual in the sense that like there's things that I kind of don't understand, but I can see that they work, so I just won't really comment on it. But like I understand how all these pieces fit together, and like I may not like remember immediately like how they are connected, but I do know that they like there's a math to it almost, you know?
Mm-hmm.
I don't really know. Yeah.
That's awesome to hear. It's really like, I think that's the secret to circuits, is that if you can first worry about the like math, like you said, there's a math to it of like this plugs into that, and then boom, it works. Like if that's your first level of understanding, then if you want to, you can go deeper with flybacks, diodes, and back EMF and all of that. But like you don't need that to get started. You just need to know like, okay, I plug it in here, plug it in there, and when I write the pin high, it turns on the light. And if you can stay focused on that, it's awesome.
Yeah.
I love that this came together. Do you have the lamp nearby?
No, I left it at MakeHaven, and I haven't been able to get there because of the snowstorm. But when these nanos come in, I'm gonna like, I guess what I'm also trying to say is like, it's like I don't have it all like together still, but I understand like the steps that I kind of need to have it like all together. Like I have the blueprint. I kind of just want to be able to figure it out and put it together without like, I don't know. You know what I'm saying? Yeah.
Yeah. It's very gratifying to do it on your own, like with a guy, like with, here's the map, this is what we do, and then you go. So I'm excited. I think you're gonna have a really cool lamp by the end of the week, Ruby. I'm looking
excited
forward
to
to
show you guys next week.
Yeah, that's awesome. Cool. Okay, let's see who would like to go next. We've got
I'll go.
Yeah.
Well, I had a lot of success and failure this week. I had, I'll start off with the bad. My main intention was to really get down with the PIR module, and that's pyroelectric, right? Yeah, that's what the pyroelectric. Yeah. And so I learned a lot about it, and it was the one module I had the least success with. I was going to integrate 3 more. I bought some cheap, like a 3-pair kit for $5, and I think they all came dead on arrival. And then the one I have, I've been using for the past year, and when I first used it, I've never had any problem. It was one of the easiest modules to work with. But now that I've been working my own code into it, maybe it's a code problem, but I've run like about 4 or 5 other people's codes from Arduino, and it will run, but it'll be choppy. and inconsistent. So that was very frustrating, but I'm gonna just chalk it up to maybe it's broke, maybe I just used and abused it too much, you know, and I'm gonna just keep trying. But it gave me the opportunity to play with other things like capacitive touch. So I hooked that up to a plant. I hooked it up to, what was the thing I made? It's not exactly a relay or a solenoid. It was a nail with the copper wire wrapped around.
The solenoid or electromagnet.
Yeah. So I played with electromagnetism, hooked up ground and 5 volts to that, and was able to, you know, pick up other metal objects with it, and experimented a lot and asked a lot of questions about just theory too, like theory that I've never understood, which has been helpful in just integrating all this in a way that sticks. So some of those things were just like, why does electricity or electrons, why do they prefer to always return to ground? And things like that. And maybe I don't 100% understand all of it, but like I do get more of it. And the video you made was really sweet, and that kind of all brought a lot of stuff together, specifically with the pull down resistor.
Yeah.
So yeah, now I totally get that, and it makes sense. And yeah, so
cool.
Frustrations and successes, and I learned through both of them this week. So
that's awesome. Yeah, it takes all kinds of different experiences to make sense of it, and usually it's frustrating, but I feel like you often learn more from the things that don't go the way you want. If they just go buttery smooth, usually it's like, oh, that was great, I don't know what happened, but it happened. And so it's when things are hard.
Yeah,
absolutely.
And
so,
yeah, and you sent me like one article I didn't get before, and so I read through that, and I just like learned a lot about this particular, you know, input device.
Yeah, that's awesome. Yeah, it's totally amazing. There's the physics of all of these things is really deep, so you can go way down the rabbit hole if you want to learn all of the specifics of like the right hand rule of how the magnetic field coils around a wire and like all of that. It's probably not immediately necessary to just like get things up and running, right? Like to get to connect things. And so it's really cool to learn that sort of as you go. It's actually, that's my background is in teaching physics, right? And so I was classically trained in a way that like had none of these applied things. I could do the math of a magnetic field around a wire before I had ever like done it by hand, right? So it was sort of the backwards way. It probably helped me pick up some of the things a little quicker, but like not substantially. It's totally a skill that the practical side of understanding and then the theoretical side of understanding. The world somehow likes to keep those separate, but I think that as you get more invested in like you put in, you know, I imagine a future where Aaron's put in 50 sensors and Ruby's put in 100 relays to control a whole army of cloud lamps, right? At some point you're going to be like, well, how does every little detail of this work? Like I want to know the nuts and bolts of all of it. And so as those questions come up, you'll just naturally want to know. And so you'll get to a deeper understanding that clicks in your brain better than a textbook ever would. So
totally. So yeah, after I asked a few questions and I got some theory down that I never got from other people, I then just put that away and started like getting my hands on stuff and having successes and failures. And like you said, it's, you know, the theory is all good and all that, but like but I learned just as much, if not more, through just doing it. Yeah. But sometimes that theory is really important to do it. So that's when I kind of like let myself go down the rabbit hole a little bit. So.
Cool. Awesome. All right, let's see. We've got Lila and Anna. You want to go for it, Lila?
Hi.
Hi.
So I'm a little behind on the Arduino stuff, but at the same time, I feel like I kind of already did some of it that I just need to go back to and fix it. So right now I caught up with the 3D modeling and I'm excited and I want to show you what I made.
Ooh, that
Yeah.
sounds exciting.
All right. Well, all right. How do I share it? Let's see. Here we go.
Which actually brings up a good point while you're figuring out the sharing, if you don't mind me talking for a second.
No, go ahead.
We're gonna be after this is our last Arduino week for a minute. Whoa, that looks great. And then we're gonna head into CNC, so it'll be more geometric and more making. So think about Shipoko badges if you're looking for some time. But I will be quiet and let you show us what you made.
All right, so I followed a Linda tutorial and it kind of brought me through the steps of starting off with making this out of a rectangle and some ovals that I lofted together, and then I mirrored over a plane.
I
and
think it might be on another screen. I see a blue background.
Shoot.
No, you're good.
There we go. All right. Did that work?
Yes, yeah.
Okay. So yeah, this started off as a Linda tutorial and I made a rectangle with some lofted ovals, and then I mirrored it over and it was neat. You gotta then I cut it in half, and I still am not great with the
Oh man, look at
learning
that
how to do things, but I made ribs on the inside and I screwed it together. It's still missing a few things, but it's getting there. There's only one part left. And so if I hid something, do you know how to get it back in SolidWorks quickly? I hit tab. It's not tabbed to get it back. I just lose things.
Oh, geez. No,
but I know there you can get it back. There's a longer way.
You totally can.
Yeah.
It's been
so I'm learning little things like that. And that's all I did so far. But
that's awesome.
It's kind of a lot. And I learned a lot doing it, and it's been a while since I've used 3D programming. So I'm excited that I got this far with it.
Yeah, that's fascinating. You've got those lovely organic shapes on the controller. Like you're able to do most of the stuff that I design is just blocky. It's really neat how well you've got the like curves and details of that. It feels totally like something you could just pick up and play with.
Yeah. I highly recommend the tutorial if anyone is wondering how to do SolidWorks. There were some parts where I had to watch over and over, but it was pretty good.
Yeah, SolidWorks is really it's like industry standard for sure.
Did you choose the controller, or did the controller choose you? How did you decide on that?
So I went into Linda and it said, here's a tutorial on how to make an electronic part. And I was like, that looks like something I could do with a little work. And that's how I did that. So, and they actually had another tutorial in there that made something similar to what Wagata made with the assembly for a board, like a little case. So I don't know, that was in there. Like, oh, I could have told them about that last week. But anyway. And I was thinking for the next, what we just talked about, I've always wanted to make a speaker. Is that something that I would be able to achieve, or is that a little out of my touch?
Oh, like to build. So I have follow-up questions, but the short answer is it's possible.
Okay.
You want to build like the cone itself, the part that makes the noise, or are you thinking like the enclosure for the speaker on a CNC?
I was so something that would be relating to what we just did in this topic.
Oh yeah. Let me.
If not, I might, I'll stick to the little motor you were very, very enthusiastic about.
Yeah, the motors are great. You're gonna love them.
You love the motor.
You will. But I can also the styrofoam plate speaker. If you have access to an old amplifier, or if you're very diligent about wrapping the coil so you have enough ohms of resistance, which is really actually henries of inductance, but if you wrap the coil enough so that it doesn't blow your amplifier, you can make by hand your own speakers. You just need a really solid magnet, a permanent magnet. And then basically I'm sure everybody's seen like the sound wave drawn out on like a equalizer or something, right? Where music's playing and it's a sound wave and you've seen that go. If you take that sound wave and you map it to an analog voltage, whether it's through pulse width modulation or whether it's like a legit analog voltage, you can get, what that does is it takes the electromagnetic coil, and if you imagine that's a coil and there's a permanent magnet, it will move the coil up and down, like attracting and repelling from the base, which feels like a foreign thing, but you've totally seen a speaker shaking before.
Yeah.
And just an electromagnet that's moving a cone of paper up and down and a really heavy permanent magnet at its base. So it's totally possible. I used to do this with my physics students every year, like the end of the year when the seniors were ready to graduate and didn't want to do anything substantial. But I made one speaker that I used for years afterwards because it was just like such a wow of a demo. I mean, it's not going to be like, don't expect to outperform Bose on your first attempt making a speaker, but you can make a pretty awesomely good speaker if you take the time to delicately wrap the coils, if you put a little bit of glue on them so they stay in place and you don't get coil line, and like really do a nice job. You can make a pretty good speaker just by hand.
Yeah. So that's been on my mind for thinking.
Yeah.
But if not, I'll try to come up with something else.
Yeah, you'll have some fun. I'm sure.
Yeah. All right. That's all I have. Next.
All right, we've got Kate is here, and you've had a week, so you don't feel like you need to share anything. That's totally fine. Are you excited about something for this week?
I will just say that, like, I spent a long time trying to figure out parts and pieces, like what kind of sensors and trying to get them. And then it was the weekend and I was like, what? So
yeah.
It was sort of a part situation. So I want to try to get back on top of that. If you didn't see in the chat, anyone, the parts that Corey asked me to order, motor parts and other things, are supposed to be arriving Tuesday. So we'll let you know when those are available on the shelf. And hopefully I can figure something out with them.
Yeah, awesome. And actually, I've got a part coming in Tuesday. Also, I ordered a V-bit so that I can see real fancy letters. And so that's coming in for me on Tuesday. And my hope is that I'm in Tuesday or Wednesday to play around with that, to be around for sensors. And then I'll as long as it's not Snowmageddon, Thursday and Sunday, I try and be here reliably, right? Silly New England snow. All right, and then we've got Anna and perhaps Ada is the other name on there. Anna, how you doing?
Yeah,
that's okay.
I don't even know what to show. I made this in Shaper, but I'm not happy with it. And you can't even see it because of the way
It's very bright. If you get it closer, I think it'll stabilize.
Yeah, bring it
So
closer.
I was starting to see it.
Yeah, it was starting to white balance.
Hold on, I'm trying to.
Yep, it's white balancing.
Yes, yeah.
Oh yeah, that's actually great.
God.
It's like a complicated little mechanism, lots of detail.
Yeah, I followed a tutorial, but I'm not really happy with the way that I built it because I feel like there's a lot of parts that like look like they're connected, but they're not actually connected. Like, but yeah, so like that's in Shaper 3D, which I like because I can use my Apple Pencil and actually physically like draw circles and rectangles and stuff, and that like kind of makes it makes more sense to me, like diagramming wise. And so I feel like I've successfully built something faster than I would have in Fusion 360. I've really struggled with Fusion 360 when it's like anything other than the doghouse. I guess apart from that, I got badged on the laser, and I cut some stuff out of this is cotton rag mat board, which is like a little bit thicker than regular mat board. And I just cut out a basic star shape a bunch of times, and then I made these.
Oh, are those earrings?
Yes.
Yeah, that's awesome. Those are lovely.
I had to put them on something to show you because like I kept trying to like take pictures of them and it wasn't working. I don't know why I'm so washed out. Like I'm using the same lighting I use every Monday, but for some reason. And then I guess that's like pretty much it for now. I'm getting badged on 3D printers tomorrow so that I can try and print this thing that I just built. And so I'm taking it over to Slicer and trying to get that set up and get STL file.
Cool.
But yeah, so that's what I got. I have no idea what I'm doing this week. I have no idea. Like I kept trying to do something with the light sensor and I just wasn't really understanding what I was doing. And I just kind of felt like I was plugging things in and like getting the same reading the whole same time. And I was like, this is not the same conditions. I don't know why I'm getting the same reading. So I have to like figure out that. And I don't know. I have no idea what I'm doing this week.
Yeah, don't feel, one of the things that I think is really important is that on any given week, there's several people that go after like a whole project in a week. It's totally okay to have a week where you're like, I just want to blink some LEDs, right? I'm not trying to solve a major problem. Like this week very much would be okay if your goal is just to make a servo move, like to wave a flag, regardless of how loud it is, just like getting them to move. So playing around with that is a totally reasonable goal. So let's see, we've got Ada has put her name up. Have you been, you want to say hi, Ada? Are you good? You're headed back to New Haven, right?
Yeah, I can say hi, but I don't really have anything to show. And also my internet connection has been unstable this entire time. So hence the no video and stuff. So I'm liable to start cutting out at any moment.
Well, you're all good. We're glad to hear from you and excited to have you back in town. Yeah. And it seems as though we're recording, so there'll be all sorts of internet access for these things coming up. I actually really appreciate that we're recording these just to have them as like a history of what all we've done, to see what's going on. So
yeah, I'm definitely going to be watching the recording of this one because I think I got about maybe 55% of it.
Yeah, yep. I've definitely been in those meetings before. Luckily, I try really hard to make sure I'm in a good spot for these ones. So, yep. Awesome. It sounds like we've had a big week. A lot of things happening across the board. I'm real excited to see what's going on. We've got one more week, like this week is electronics-y sort of stuff, and then we're gonna head into CNC. So CNC is computer numerical control, and I was just talking this afternoon with Lior. We're gonna try and figure out ways to make sure that the Gerber is as sturdy and stable as possible. We're very excited to see it go. That's what I bought my bit for. That's coming in on Tuesday. So we can do fancy lettering. But the hope is that you could all design and play around with CNC machines. And there's, as I count, I would say that there's 3 in the space. There's the Shipoko, which is totally a CNC. It's adorable. Works great for lots of little things. I would say it has a fair amount of wobble in the spindle. It's not like high precision. You're not going to make a circuit board with it. The Gerber is going to give you great detail for wood size and scale things. You can make some really funky furniture. You can make all sorts of things. I've in the past I've used CNC to like slap a sheet of plywood on a CNC like the Gerber, and then 20 minutes later out pops a table that I can have students working at, and if they put a drill through it, it's not a big deal. So those are really interesting things to be able to do with a Gerber. And then the third CNC, and this one's probably not gonna be anybody's reach for this week, is the Tormach for those 2 weeks is the Tormach CNC. Although I'm trying to get that one in the metal shop, where it's got the most rigidity of the three, the most control, and it's really able to do some high precision stuff. And if you've been paying attention, Andrew put on Slack, I think in the Made at MakeHaven just a day or so ago, he put out it's a bottle opener that's really, really good for yeah, that metal bottle opener is really cool. He cut that on the Tormach. So that's totally CNC done. We're going to stay focused on VCarve because I think it's a little bit more approachable, but you can absolutely you can absolutely design for full geometry cutting and all sorts of crazy complex shapes. We're gonna stay focused on, you know, like things that can be achieved in a week or two. So on the Shipoko, that's the name of the software just lost. Easel. We're gonna focus on Easel, and then VCarve is the other one that's really helpful for running the Shipoko and the Gerber. So we'll be playing around with those quite a bit. So it's exciting. There's lots of good options. If you want to think about making furniture or big things, you could check out OpenDesk if you want to like look forward into big built models. There's tons of things. Kate, what's up?
When we're talking about CNC, what about the water jet?
Oh, the water jet would also totally count. I was just thinking about spinning end mill bits, but the water and that's the only reason why I counted not the water jet, but the water jet would totally work, and you can cut through whatever you want on the water jet. It will cut through metal or glass, or I'm sure you can cut through wood. It would just be wet at the end, which is probably fine.
Don't put it on the saw stop after it's been in the water jet.
Oh yeah, good call. Don't do that, because then you'll have a broken blade and a break. So those are all fascinating.
But you could cut stone in the water jet, which is just super cool. You've done it some, and I would love to see more of it happen. And vinyl records. So
that's crazy powerful.
Yes. Yeah, since the water jet came into existence, I've repeatedly harassed Carolyn about I want to put our names in a bathroom floor at some point in the future, like to just tear up the tile and like put our name. We're renting, so not right now, but it's a life goal to put my name across the bathroom floor. Maybe that's a weird life goal. I don't know. It's one of many. I thank you for validating that it's a weird life goal. I appreciate it.
Well, Gunnar, were you saying something before the water jet?
Oh no, just that there's like a video I saw a while ago about like water jet cutting through ridiculously thick stuff. It's like pretty scary. Yeah, I didn't realize. If I find it again, I'll put it on the Slack.
Yeah, it really can cut through whatever. It's just the dwell time. So how long it stays in an area, it sort of moves the jet of water down through, because there's essentially the air is just sort of gone out of the way. As long as it stays in one spot, it'll just keep drilling down and down and down. So like 6 inches thick of steel can happen. You're just going to sit there for a long time, which is nuts. Stone is a really cool one because stone is hard to cut otherwise. It's very brittle. So it breaks apart. So all sorts of interesting things to see happen. I'm excited for what's going to come up this week. What sort of outputs? I'm excited for little teeny robots that like do a dance. I think that'll be great to see. I'm excited for the CNC for where we're headed. So if you wanted to start to think about any of those things, if you need any help this week, I'm absolutely around and able to do any of that business. So I'm in. Let's see. What's up, Kate?
I just had a sort of general class, as a pilot group class question that I wanted to put out. And Corey, you may have some logic behind this that I don't understand. But it just occurred to me, I'm curious why we do lecture and then show and tell rather than the other way around. And my thinking just being that it's like we finish something for the week, and then we, like, to my brain, it almost makes more sense to start with the show and tell as a way to wrap up that week and then move into the next thing. I'm realizing I kind of feel like we do a lesson and then take a step back to the last week. And
you're completely right. It is a valid question, and it was, I'm going to say, largely an arbitrary choice. The idea that like the show and tell is a look back, so it makes sense to keep it continuous. It also, I think that there's value in sort of leapfrogging. Like, brains aren't quite as linear as sometimes the stories we like to tell ourselves, and so going back and forth a little bit can be helpful. But if you all wanted to switch and do show and tell first, I'm game. Like, that's totally fine with me. I've got no problem. I think it's probably, honestly, it's the time thing, that it's easier for me to track my time to stay close to an hour, which I can't always do. And then we can sort of wander, like, we're 7 minutes before the 9 o'clock. So it's, the show and tell is more organic of an ending. If somebody wanted to watch the recording, it's just like,
so we get to start with dessert instead of having to eat dinner first?
That's right. How can you have any pudding?
That seems so not like an adult thing to do.
Oh,
it's a pandemic. We should all be eating dessert first. But to your point about timing, Corey, that's a really good point. And I think Ruby was on board with you too. I wasn't suggesting that we flop it. I was just, it's one of those things that several months in just kind of like occurred to me. So
yeah, no, we could totally, even if we wanted to try 1 week, we could totally just do that and then like crop it for the video. But those are all, any suggestions you guys have ever, please just voice them. It's good to hear. Also, we're putting together a tentative plan for like what all the weeks would be and what would be a possible wild card week or two coming up in the future. Like, we're just sort of plotting out all those things. Once we've made sure that we haven't missed any pieces, we'll push that out and make sure that it's available. Like, I think Kate pointed out that I forgot in the tentative one that I wrote up, I might have forgotten the bio week, which I don't want to forget because the bio week is going to be cool. The tentative plan is to pull in, it's a really good like college biology lab where you'll swab your own cheek, collect your own DNA, and then do a gel electrophoresis where you can watch your genes like separate themselves out across a gel lab. It's a really good like CSI intro video clip is what it is. And it'll be super fun because it's your own personal DNA that makes it happen. And you get to try like a lot of the different tools in the space. So yeah, probably not CRISPR. There's many things we can do, some things we can't. And so gel electrophoresis is a great place to start. But yeah, all sorts of cool.
So we'll finally get to the answer to the mystery: who stole the cookies from the cookie jar?
That's right. We'll know because we'll have gotten electric. We'll just make more cookies. This is a maker space.
Exactly.
That's right.
What's a CRISPR?
Oh, CRISPR is it's a technology. I want to make sure that I'm not mixing it up, but it's the technology where you can sequence DNA and do all sorts of crazy stuff with it, right?
Like for gene editing.
Yeah, you can edit genes in a way that like makes it not that hard. Like you can say, oh, I would like this gene.
That's cool.
Yeah. Right. It's like one step closer to continue the Pokemon theme. Start with a mouse or a small rabbit, add an electric eel, and boom, Pikachu. There it is. Like where you can gene edit like that, and then you make your own Pokemon.
I'm getting a strong visual of that.
Yeah, that's exactly what you should be thinking about.
I'm hearing the theme music playing in the background.
Oh,
yeah. Yep. So those are totally things that we're headed towards. Very excited to see that happen. And so there's all sorts of interesting things. Yeah, there's tons of capacity for it to work. one of the, and this is maybe we've just wandered off topic, but one of the things I saw recently is like all of that DNA editing and moving around is, I'm fascinated and would love to learn more about how it's connected to the mRNA vaccines that everybody's clamoring to get their hands on right now. And like, how is that related? How do they connect? I would love to know more. I'll put a link to a Curbsiders podcast where some doctors who do Carolyn is a part of this podcast, but it's like doctor to doctor podcasting, but they've made an episode for lay people to better understand like the technology. All of this mRNA stuff that we've heard over and over is brand new. They've actually been using it for not infectious diseases prior to now. And so that's just like a fascinating tidbit, that the mRNA vaccine that you might have heard people say is new, the core of that I learned from this podcast is not quite brand new. It's been used for other things before, for different types of therapeutics and medicines.
So is a bio week going to have like any chemistry aspects to it, or is it just like DNA types?
I mean, micropipetting and all those sorts of things. I would count that in sort of the squishy parameters of biology / chemistry, like very small volumes and controlling things and like being able to do that. Maybe not in the strictest sense it's chemistry. It would be things you find in a bio lab at a college, not so much in a chem lab. But there's a point where those aren't totally separate. Oh yeah, there'll be micropipettes. I'm tempted to just run into the room and grab one and like show you the micropipettes where you press the button and it pulls up a very precise amount of liquid, and then you can press the button and then it dishes it out. There's super fun tools that make you feel like you're sciencing really hard.
Do we get white coats?
I've been corrected many times. You can have a lab coat, not a white coat. Yeah, white coats are for doctors. Those of us who wander around in labs get to wear lab coats.
I'm gonna make my mom
different links for different designations.
Oh, yeah.
As I learned in the hospital, you can judge someone's experience level by the length of their coat. Weird.
Ruby, you were saying something?
Oh, I was just gonna ask my mom to get me a lab coat. Not the lab. The white.
Oh yeah.
We have some in MakeHaven that people use as like smocks and stuff. So we also have scrubs for the same purpose, but feel free if they empower you to put them on. And a welder's mask just for fun.
I mean, yeah, that way you can almost see what you're doing.
I sometimes put on the welding like flame coat just to,
show that your business.
Yeah, absolutely. Get pumped up to run the laser cutter, whatever.
Yeah. I've totally seen people wear welder jackets as like biker jackets on a motorcycle. So probably would actually do some pretty good protection.
That's high fashion.
Yeah.
What was that gel that you said that we'd be making? Some electro gel or something?
Gel. It's a gel electrophoresis. So you use like a high voltage, you put charged particles on so what it does is it swabs the DNA out of your mouth. You like grab it, you pull it out of the cell, and then you get charged particles to bond to it, or it has some charged particles, and then you apply a whole bunch of volts. And so then it pulls all of the particles that are electrostatically attracted through the gel. But the gel like acts to slow them down. And so it takes your DNA and like separates it out into those like barcode looking things. So if you've seen barcode kind of DNA, that's what we're looking at. I'll put pictures in the chat for sure. Yes, you could absolutely swab pug DNA, 100%. It would be a lot of fun to see that.
What Pokemon would a pug be? Or is it just like, am I taking it too far?
It's its own Pokemon.
Yeah, I think so.
I think there is a pug Pokemon now with the newfangled ones that the kids are playing. I did stop at some point playing Pokemon.
Sure.
Hey, don't. It's fine. It's fine. We're gonna edit this out, right, Kate?
We can settle this with our Pokeballs.
Yeah, we sure can. So yeah, there's all sorts of fun plans, things that we're gonna be doing and making. And when we get the final schedule, we'll put it out. the wildcard weeks, I think, would be a great time to get caught up on anything or do whatever is most important for you. And so, and you'll know what that is without needing to say, like, there's sort of like this week we're trying to do outputs, but a wildcard week would be just whatever it is you need to make happen. So whether that's, Kate had some good ideas for like getting a badge on something that you've never gotten badged on before, or getting, you know, like getting a website caught up, or whatever, you know, whatever it is you feel like doing on a wildcard week, you just go for it. One of them, I think probably I'll still talk, and then one of them will just be like, just go for it. Use the time to make progress.
I would also like to put out there, and I don't know that it's anything we can incorporate into this year, but you know, the units as we plan them are still listed on the Foundation's site, and we're kind of putting together the coming weeks. And if there are areas that you feel like we're lacking that are in the App Academy world, in MakeHaven, that you want to put out there, we can, you know, I think that's good information to know.
Oh, totally. Like I think what I would love to have done is drug out a little bit of extra time for screen printing, because it's such a big part of it. There's like a whole section that really can nail it for printing in MakeHaven that we didn't go into as much as I would have liked. That's a good wild card example of a thing to go into that in a future year we can make sure is more integrated. So we're thinking about all those sorts of pivots to add and make and see how that goes.
Or if we also talked about maybe if there's something you want to go back to, like I want to go deeper into welding or something like that, or even just general information for the future, like we need more time for X or whatever. That's always good for us to know.
Yeah, totally. Wait, is that a fairy Pokemon Pug? Oh my God. What a world we're in. I love every bit of that.
Kind of got a little bit of like the Yale Bulldog, like.
Oh, this may be a new mascot for the class. I don't. I'm feeling it. It's gonna happen.
I like how it's pink. I dig that.
Yeah. Save and then open. It's taking a little while for me to get to it. Boom. I gotta find this thing. Oh my. Yeah. Look at that guy.
You know, we should have, guys. Oh my God, we should have a yearbook.
A yearbook?
What do you think? I have this idea. Oh my God, it's perfect. We have to do it. This is our mascot. All we need is like our little pictures cut out, and each person gets like a yearbook with everybody's picture in it, and then you could like write a little note underneath their picture. We could totally do that. I'm just saying, it could be laser cut. It's
during the gather portion of the annual meeting. I know people were around at different times, but I was asked by non-Foundations students if we would be having like a graduation / show, which I think would be awesome. I know it's going to be tricky depending where vaccines are and stuff like that, but even, you know, by that time we could also even do something outside that could be larger. So
yeah,
God, outside.
And an exhibition, you know, like our projects could be like on pedestals or like on a table or like on the wall.
We could probably like rent a gallery. Probably wouldn't be like that difficult.
I would love to have like a little art gallery of the things that we've made and just sort of hang out and say like, here's what we did. JR was thinking about it as also like a good advertising moment for people who would want to sign up for next year. And so those would all be really cool to see happen. It's actually really exciting that people are asking about, is there going to be a graduation like presentation? I think art gallery is a great way to think about it. Like all these weird things we made, you can chat with us if you want, but it's less formal than a presentation sounds right. That feels right. So don't worry about the finals. We're building there.
What is that? Well, I don't want to like, I know it's 9:06, but I'll ask this quickly. Like how long are we gonna get to work on our final projects?
So that's a really good question. And so one of the things that's worth it, as we're like about the halfway point now. So I think that an important piece is to start, and we're gonna tentatively, I'm planning on a wildcard week within a month. So I was thinking that I would say that might be a good moment to start to think about what your final project could be, even if you don't know, like don't have it totally put together. be good to start to think about it. The last 2 units before like we get to the final weeks, the last 2 weeks or so are just like conceptual. There's no specific thing to build, so they're dedicated time to work on the final project. But then the 2 units before it, machine design and mechanical design, those are sort of group project things. And depending on how quickly those come together, they may be great times to be working directly on your projects in parallel with the group project. So I think that you're going to have sort of 6 weeks that are kind of free-ish to work on it. But if you have an idea and know what you want to be working on, there's no reason you couldn't be started. As you all know that this is sort of spun up from Fab Academy in a few ways. But in Fab Academy, they would say, if you know what your final project is going to be walking in, you can make every week count towards it, which feels like a really impossible goal. But it's the sort of thing that they tell you in Fab Academy. And in here, like as you start to conceptualize, like, oh, I want to make a coffee table that is a Zen garden also that moves on its own. If you imagine that, and then you start to think about how would I make that happen. I know that's probably going to be my final project. Although unless somebody else wants
I
to take it.
seriously have that Instructable pulled up right now.
Oh, there you go. Good for stepper motors. I was going to just make mine from scratch. The goal is to try but please take it, Kate. The goal is to try and have something that you can say like, oh, I want to do outputs, but maybe I want to work on steppers because I'll need that for my Zen garden table, right? And there's some logic to that. It can also be very frustrating if you're not making the progress that you want. So you spin around, take a little time, think about what you want to do, but definitely start rolling around in your head. Like these areas I like more, these areas I, wander away from a little bit. Like, what do you want to make your final project be about? What's the spirit you're going for? And then imagine from there. So yeah, it's all exciting.